Hello everyone, it's Mantas from Matiaka. So welcome to last part, so part 4 of edexcel past paper tutorials. So today we're gonna do the rest of the questions which are in the end of the paper. Supposed to be the hardest ones, but what I've noticed in previous part I made a silly mistake which I would like to revisit. Okay, so this one, everyone does mistakes, so we need to celebrate that. So where is it? Yeah, it was in one of the swords question. Yeah. So in this bit, what I've done, I accidentally multiplied 3 by 3, and what it means, it's supposed to be 3 multiplied by itself 3 times. So in this case, it shouldn't be 32 take away 9. It should be 32 take away 3 times 3 times 3 makes 27. Okay, so take away 27, and that brings us to answer of 5. So even with that mistakes, you would be getting 2 out of 3 marks. However, make sure that try to avoid those mistakes. Okay, of course it happens to everyone, so let's get it corrected so it's equal to 5. Right, so once we've done that, we can start on the last questions. Okay, so we've got some cuboid, okay, and given 2 sides, so AF, so just find where it's got side which and starts with A and finishes F. So we've got 6.8 there, and we've got FC. Where's FC? Okay, so FC is that diagonal of the cube, so start with F, and let me just draw the diagonal. Okay, so diagonal inside the cube is FC, and that's equals to 13.6. Okay, and work out the size of the angle between FC and plane ABCD. Okay, so what it means, we need to work out the angle between this line FC and diagonal of that rectangle. Okay, so I need to draw another line, so I need to connect A with C. Okay, and that would be the angle we are looking for. Okay, so it's between that rectangle and this line FC. So what I would recommend you, I would, of course, that's the still perpendicular angle. Yes, so it's because FC is perpendicular to not only to AB, AD, but to all the plane. It's also perpendicular to AC. So what I would do, I would just drawn a quick diagram of triangle related. So just imagine we've got AF, okay, and we've got C. So just redrawn this right angle triangle from 3D shape, just made it into 2D. Okay, and let's label the sides. So we've got 6.8, we've got 13.6, and the angle would be FCA. Okay, so now once we've got that, just use trigonometry. So we've got the angle, we've got opposite, and we've got hypotenuse. Okay, so opposite ratio of opposite divided by hypotenuse is called a sin. Okay, so just if we've done that as so, okay, and ta, do the sin triangle. Okay, so to work out sin, so if we've got opposite and hypotenuse, that will bring us with sin ratio. Okay, so let's try to put it into equation. So sin of angle C, so I can just label it as sin of angle C, would be equal to opposite, which is 6.8. So 6.8 divided by 113.6. And what we can see, what I can spot without calculator straight away, that 6.8 is a half of 13.6. I can just put 1 half, and I know that if I got sin ratio of half, the angle must be equal. So if I do sin of half, if I want to work out what angle represents ratio of 1 half, I just do sin minus 1 of half, and that angle will bring us 30 degrees. Okay, so which means angle between this FC and the plane ABC will be equal to 30 degrees. Okay, now moving on to next question. So of course it's only 2 marks, but still worth to get. Okay, so write the irrational subtraction of irrational fractions in form of rational fractions. So first, what we need to do, we need to rationalize the denominators. Okay, so do that first. So I'll do it separately. We'll start with the first fraction. Okay, so we've got 3 root of 3 over 4 minus root 3. So in order to rationalize that, I need to multiply it by 4 plus root 3. Okay, so I multiply, just use the difference of 2 squared, because I can't just square it, because if I square it will make a different fraction. So I need to multiply both bottom and top by 4 plus root 3. So I could use difference of 2 squares, so times 4 plus root 3. So if I multiply by the same expression for top and bottom, the fraction does not change. Okay, so now expand the brackets on top, so we get 12 roots of 4, so 12 roots of 12 roots of 3, then multiply it by 3, we get 3 times root 3 squared, which will just give 3, so 3 times 3 makes 9, so plus 9 over there, and I can use difference of 2 squares there, whereas 4 squared minus root 3 squared, so 4 squared is 16 minus root 3 squared is 3. Okay, so I have done with first fraction, so of course that will be equal to just collecting like terms, which is 12 root 3 plus 9, just simplify as much as I can, over 13. 16 minus 3 makes 13. Okay, so done with the harder one. Now next fraction will be 2 root 3. All I have to do, just times 3 on, root 3 on both top and bottom, which will bring us to 2 roots of 3 over 3 times 3 makes 9, so 9 square root of 9 is 3. Right, so once we've done the first step, next bit is we need to subtract those. So I'll do 12 root 3 plus 9 over 13, take away 2 root 3 over 3. So let's do that. So 12 root 3 plus 9 over 13, take away 2 roots of 3 over 3. So two fractions with a different denominator, so I just times first fraction by 3, both top and bottom. second fraction, to make a common denominator, I need to times by 13, so times both top and bottom by 13, which will bring us into 3 times 12, 36. I just get 36 roots of 3 plus 27, take away 26 roots of 3, and all that over 13 times 3, which is 39. Right, so last step is just collect like terms in numerator, so 36 take away 26 makes 10 roots of 3, still got plus 27 over 39, and that would bring you whooping 4 marks just for doing that. So let's check. We've got A equals 10, B 27, C 39. Right, so moving into next bit, so just make sure you write down the answer, but usually you're not getting extra mark, as the people who marks those tests, they just check your working out anyway. So plus 27 over 39. Right, so move into, I think it's gonna be the last question, so 5 marker. Yeah, so it's on one page. So for the last question, find the set of possible values of x for which both inequalities are correct and must show all working out. Okay, so we've got simultaneous quadratic inequalities, so let's start with the first bit. Okay, so we need to work out when 4x squared less than 20. So let's do that. Okay, I'll just put less than 25. Okay, or no, actually I'll do the other way. So what I've noticed that there's a difference of 2 squares, and what I can do, I just do split into 2x squared minus 5 squared. Okay, so I just split I just made the difference of 2 squared. Now I can just put into formula of 2x minus 5 and 2x plus 5, all of that less than 0. So it will be slightly easier to work out this inequality this way. So what we can notice that what happens to the left side, so it will only be negative when we've got different signs. Okay, so when either first term is positive, second negative, or if first is negative, second should be positive. So I need to first work out the critical values of x. So in this case, if we've got x, one of the critical values here is 5/2. Okay, so checking when this bit is equal to 0. So this bit will be equal to 0. The first bracket will be equal to 0 when x is equal to 2.5. Okay, so I can just put 2.5. The second bit will be equal only if x equals negative 2.5. Okay, so let's check with the graph. Okay, so let's check with the graph. I can do I can sketch the graph, and it will be easier to visualize. So I know that I need to use empty marks. Okay, so in the sketch of graph will be, it doesn't have to be accurate. I know that we've got quadratic graph, and we need to look for the values which will be under the x axis. Okay, so we can't use this region. We don't use this region. As we can see, graph is positive, graph is above x-axis. We can't use this region neither. Okay, so the only correct region is in between -2.5 and 2.5. So that's what we get from the first inequality. So x must be in between -2.5 and 2.5. If we want, we can check. For example, if we substitute any value in between that region, we should get a negative. Okay, so for example, I choose 0, so 4 times 0 is -25, which satisfies the inequality. Okay, so once we've done with the first one, do the other one. So we've got 12 minus 5x minus 3x greater than 0. I forgot to put square. What I like to do here is to rearrange it, and rearrange it by multiplying everything by negative sign, because I like it. I like quadratic expression to be in the form of ax squared plus bx plus c. So where I start with the highest power, then lesser power, and then the y-intercept in the end. Okay, so if I times both sides by -1, okay, all the signs will be changed. So I'll get 3x squared plus 5x, and 12 becomes negative, minus 12. Now when multiplying or dividing by negative, be careful, because what happens, it swaps the sign to opposite. So if we had like more, okay, that more turns into less than 0. Okay, so what I've done is just times by -1, which swaps positives into negatives, which basically flips the x-axis. Okay, so we've got another quadratic. I need to work out where the this quadratic becomes 0. So I solve it for 3x squared plus 5x minus 12. I just rewrite it as an equation. Okay, and we've got a coefficient is not equal 1. So if a coefficient is not equal to 1, I don't like to use discriminant, because there's loads of calculations, and there's loads of space where we can do an error. So instead of that, I'll just do a C method. So what I need to do is get a coefficient multiplied by C coefficient. Okay, so 3 times 12. Okay, so 3 times -12, I get -36, and check what two numbers multiplied together to get that -36. So I will ignore that negative first, because I just need the factors. Okay, so one of them is 336 and 1, or 136, and check if I could combine a 5 there. So probably I can't. So next bit is 218, also can't combine, doesn't make 5. Then 312 also doesn't make 5. Then 4 9, yeah, I can spot that 9 take away 4 makes 5. Okay, so what it signals, that the 4 must be negative and 9 is positive. because I can double check that one of them, well, both factors should be with different signs. So I'll make -4 and +9. I need those numbers. So I could split middle term, which is 5x. Okay, so rewrite the equation, which 3x squared stays. Then instead of 5x, I do minus 4x plus 9x minus 12. I still set it to 0. I'm just pretending that it's equation, not inequality. I'll get back to inequality when I finish with quadratics. Okay, so now we've got two blocks. Okay, so we'll split this into two blocks and factorize separately. So factorize the first bit, which okay, so I'll move the x in front of brackets, and brackets will stay with 3x minus 4. Okay, so I factorized the first bit, and now I need to factorize the second bit. So I can see that 3 goes into both 9 and the -12, so just move +3 in front of brackets, and brackets will contain with the same 3x. It's now factor 3 out of 12, which will end up with -4 equals to 0. So now we've got a common bracket, so the same term in both in both blocks. So I can move that in front of bracket. So 3x, just move bracket in front of bracket, okay, and open up the other one, which keeps the rest of the values, which is x and +3. So the other bracket will be x and +3. So I know that my my graph will intersect x axis when x is equal. So I need to check when each of the brackets is equal to 0. So the first bracket will be equal to 0, then x is 4/3. Okay, the second bracket will be will turn into 0 when x is equal to -3. Now we'll do the same. We'll do the same graph sketch to check. So just sketch the graph more greater than x, which so I'm gonna be using for this graph, checking for this graph. So I need to put my x -3. Okay, so x is -3, and the other x is 4/3. Okay, and just quick sketch on those points. And in this case, I need to get the values. Okay, I need to get the values of this particular graph where it's under the x-axis. Okay, so where it's negative, because I'm looking for less than 0. Okay, so again, it's gonna be in between. So x must be in between -3 and 4/3. Okay, because if it's less than 3, if x is less than 3, it's going to be positive, so we don't use that. This bit will get negative, and this bit will get positive one more time. Okay, so now we've got two double inequalities. We need to merge them. Okay, so I'll do that on separate x-axis. So the first bit of axis is between negative 5 and so why did I put negative 5? It's in between negative 2.5. Okay, so between negative 2.5 and positive 2.5. Okay, so I've got this region. Okay, so I'll just show. So I've got this region. Okay, and I will plot the second inequality. So the second inequality has points in between. It's not. It doesn't have to be to scale. So between -3 and I know that 4/3 is less than, well, in this region, so I'll just plot anywhere 4/3. It's not exact, it doesn't have to be to scale, and check for my other region. Okay, so the final solution will be only those parts which satisfies both of those inequalities. So we can't use those between a -3 and -2.5 because it satisfies only for the second bit. So the where both of those inequalities are okay, just get this region from -2.5 and 4/3. So the final answer would be x must be between -2.5 and 4/3 after we merge both of them. Okay, so the final answer will be -2.5 less than x less than 4/3, and that would be your final marks. Hope that was helpful, and see you in future.